In the last lecture, we stopped at the Remix IDE and its functionality and how can we write the code in the Remix IDE, compile it, and choosing of the compiler, then go for the deployment. These are all we have seen in the last lecture. Next, we will go for the learning of the programming constructs for the Solidity. So by this time, we come to know the Solidity program has to be saved with the .sol file, sol extension. Then the first statement in the Solidity is like a hash include in C program, like pragma Solidity, and you have to choose the compiler, which version of the Solidity version you are doing. And these are the single line comments and multi-line comments. Then writing of the function. The function will always start from function with function set of some parameters. It is just like a normal JavaScript function that you write. Then if the function is a function which you are writing with some return statement, what it is trying to return has to be mentioned within the bracket like this. Function get a constant return of uint return set state data. So this is what the return statement related function that you write. So for example, if you go for the Remix IDE, in this Remix IDE, just you click on the create new file, and you can open the contract, and there you can create a new file and type score underscore example dot solve. Now you can make use of this pragma Solidity greater than or equal to 5.0.5.0. Now actually there is no semicolon at the end. So here we have seen SPX hyphen license identifier is there, that we can simply copy it and paste it here. So this is the conventional way of using it. Then we have this set function and the function. So we can write contract example contract, just like how we write the class in the same way, class name, and write. You can declare the variables with the data types like uint. You can mention 256 means which is of 256 bits. Simply uint. You can also say unsigned integer data function set uint d. So you can set the thing like you can mention what is the access specifier for this. You can mention it's a public, so it will become public access. So if it is public, then only you can access out, otherwise you cannot access it. Data is equal to d. So this is a set function. So here it is asking you some error. It is giving you some error because during the compilation I have kept the auto compile, so it is giving you directly showing you error like identifier not found or not unique. So it is uint, not unint, uint. So then after setting function get data, so this get data will not take any parameter. However, it will return the parameter. Return what type of value? It will return the unsigned integer. And whether you want to make this function public, because unless until it is not public, user cannot use it. So you can make it as public, so that you got the error removed. The reason is you have not mentioned the access specifier for this. So you can mention return, simple return statement, return data. So whatever the D was set, that is going to be returned. So whenever it was returned, then some restrictions has to be mentioned for this, whether it is a constant type or whether it is a view type. So we are going to only view it. The reason is the view of this data will vary from person to person, or that is user to user. So that reason I have mentioned it as the keyword view. So you look at the program has been compiled now automatically. This is I have kept as I have kept the option, chosen the option of auto compile. So the program was compiled successfully. Now, whenever the program is compiled, automatically you will get the ABI code and bytecode. So simply, we are going to make use of the ABI code, and we may start developing the decentralized application. So before moving on to this, first of all, we'll see the deployment strategy. So in the deployment, we can use this Remix virtual machine. Okay, and just simply I'm using the default virtual machine, and here some 10 toy ethers, toy accounts, externally owned accounts, and followed by the ethers were placed. Now go for the deployment. So once deployed, so this contract will be deployed here. So this is the contract deployed, and here if you go for the debugging, so here what is the status of the transaction? True, transaction mined and execution succeeded. And transaction hash, this particular transaction hash 0x164, this one from this account 0x5b. So from 0x5b, this was happened. The same thing we have seen in the Etherscan also. When we are running that, when what are the block created, what are the transactions generated over the Ethernet, Ethereum blockchain, that we are going to see in the Etherscan. And this particular Remix IDE is a simulation environment. That is the reason it is also showing the same type of structure. And two example constructors. Gas points are 144529 gas points. Transaction cost is this much. So that means the estimated, the allotted gas is this much, but spent is only this much. So whatever the remaining is there, the remaining amount will be returned back to our externally owned account. So input this one, and decoded input, and what is the value of this particular contract, how much cost it, the 0 way. So this is the way the deployment and this is the compilation and its debugging status you can see. Then once the contract has been deployed, so you will find the deployed contracts here. In this, you are supposed to click on the this extension. So if you click on this, you will find the parameter. So set is a parameter, set is a function, and get data is a function. Set data, since it is taking the parameter, so set data is open and can use it. Can the user can pass the values to this. If I make it as public, instead of public, I remove this public. Then you have to make it as private. If I want to make private, it is compiled. So already the instance of the contract is created here. So you cannot modify it. Once the contract instance is created, you cannot modify it. Only thing is you have to delete this and deploy again, so that you will get new instance. Okay. So in this new instance, you didn't find the set function. The reason is you have made it as a private. So once you made it as private, you cannot access outside. So the only alternative is you have to make it as public. So you make it as public and run it. Already the compilation process is going on. You make it as public and deploy it again, and delete the previous hash, previous instance. Just deploy it. Then you look at expand this particular instance. Again, you got the set function. So with this, you come to know how to write the program, simple program like contract example, and in which you are going to use the set method and get method. And you should be very careful in fixing the access specifiers. Otherwise, this data cannot be, this function or data cannot be accessed out. In the same way, while coming to these variables also, whatever the variables you declare, you int data. In case of Java programming, you will write first you will write the access specifier, then followed by the variable declaration. In case of C++, first you write the access specifier, then colon, and under which you will write list of parameters that should come under the tag specifier. Here, the way of writing is like this: unsigned int private data. Okay, if you won't mention private, then it will become public by default. Sorry, it will become private by default. It is actually by default it is private only. Then you can also mention as public, and you can directly mention as public and deploy it. So in the new instance, you will find data also. Okay, you have find data. So now without this, if I mention this, it will become by default private, so it cannot be shown outside. So here in the deployment, you will find only set and get. Since the set is a function which is taking parameters, I can pass some parameters 100 and transact. Set 100 and transact. So the transaction was successful. The value was set as 100. That is, data was set as 100. Now, if you want to see how many gas points were spent for this, just to go for debug, and you can see here, this is true transaction mined and execution success. And here, this is the gas points allotted, and these are the gas points spent for this. And after the execution of this transaction, what is the resultant you got? That is 100 is the value set. And I want to see whether the value was set or not. So here you can go for get data, click on get data. So you will get the transaction, that is you will get the result of the data, that is 100. So you can also go into the debugging phase, and you can also see how many gas points were spent. For getting the data here, execution cost is 23479. The reason is, we have seen in the last lecture that for every operation that you do in the using smart contract, the loading of the data, reading of the data, or processing of the data, or traversing the array, all these things will cost the cost in terms of gas points in Solidity. I hope by this time you come to know how you will write the program and run it. Once you run this, if you look at here, this is example.sol. Under the artifacts, under the scripts, you will find okay, deploy with Web3.js and test. These are the programs that you will find. You may use it in your regular application development. Any doubts so far? A very simple program. You may also try it from your end. You may open Chrome browser and remix Ethereum remix.ethereum.org. Just you try it and run it on your own. Just I will give you 1 minute time, and just go for execution and see whether you got the set function like this, and have you passed the parameter or not. First you check for the deployment. Before that, you go for the compiler, auto compile or normal compilation. Compile it and go to the deployment. Okay, and deployment, just to go click on deploy and check whether the contract instance was created. Just click on the expansion in the contract instance and set the value, transact, and get the value. Do you got this value? Just to check it. Just I will give you 1 minute time, and let me know if you have any doubt. So this is the set method and get method that we have seen. Next, these are the programming constructs in Solidity. What are the programming constructs? Import statement. So if you want to import one Solidity file in another file, then you can use import file. Like Solidity supports importing statement or import statements that are very similar to those are available in the JavaScript. Import file name. I want to here in this example, I want to import storage.sol, or I want to import the owner.sol. Then before this, you need to place it as import and give this dot slash one underscore uh, uh, storage dot sol. Okay, so one underscore. So this is the way you need to include import state. So one Solidity program can also be imported into another Solidity program. Then while coming to the selection construct, if else statement is there, if else statement, if condition, block of code to be executed, if condition is true. You can also check the conditions like whether the message initiator is the owner or not, or if the message initiator is not the owner. All these things can be checked with this particular if condition. Any kind of things you can go for execution here. Next is like simple example is total points is greater than bed dot line, like that you can do. Okay. While loop, just like in C programming, how you will use the while loop in the same way, you will also use the while loop. And for loop, like in C programming, whatever you use, post the simple post increment operation, post decrement operation, the same operations that you use in C programming, the same program structure will also be there in the Solidity. While coming to the data types, Solidity supports data types like Boolean that will be represented as bool, and integer operations, int that is unsigned integer, signed integer, and unsigned integer. Unsigned integers of length 8, 256 are there in the unsigned integer. And along with this one, it will also support the address. So if I want to mention the address, I can also mention the address here. Address, the keyword is address, and this address will occupy 20 bytes. That means 160 bits. Ethereum addresses will be of 20 bytes. We have seen here, whatever the address is there, whatever the address we place here is 160 bytes, 160 bits or 20 bytes. Whatever the, if you look at the account address, from which account it was happened, you want to see whatever the from address is there, this address is of 160 bits or 20 bytes. This is the Ethereum address. These are the data types, and some of the data types are like this. Address. Address is the data type. Okay. Address is the data type. It is the inbuilt data type with which you can get the balance of the current address. That is, if I am operating this under this deployment, since I am this is the first account is operating, so if the transaction is executed, it will check what is the balance of the current account. That is what the thing. So address dot balance, address dot transfer from my address to some other address, amount, send amount, like that. These are the default data types that are available. Next, what are the other data types? Arrays, bytes, okay, byte arrays. These are the various things that are available for storing the operation. At the same time, you can also perform the left shift operation, right shift operation, all bitwise operations can be done. There will be string literal, hexadecimal literals, because you are going to represent the hash code in the terms of hexadecimal. So hexadecimal literals will also be supported. Enumerated data types are also supported. Simply enum, like how you use C programming, enum, the same way enum, hair color, like that you can mention what kind of things are there. Next is structure. This is also very, very important. Now, in this program, for example, contract example is there, or you can say contract MLM, multi-level marketing, that we have seen last lecture. So struct employee or struct company. You can mention what are the properties of the company. It may be having address, company address, okay, and string name, and like that you can mention anything. So you can use this company in MLM contract, like company, uh, like company MRF company. This is struct company MRF. Uh, yeah, it is not asking you to see. Public. So it's not struct actually. Directly you can write the company here. Well, so now if I want to do something, then you have to do with the company. Like company address is company address. Then if I want to set something, then here string name, then here name, sorry, you can say here company dot name is equal to name, and here what is the error it is showing? Must be in memory. So the name must be in memory. That means some memory should be allotted for the this one. So string memory name. So for this string, some memory will be allotted. So whenever the memory is allotted, some gas points will be spent. Okay, as more memory is required, that many number of gas points will be. Then company dot company address is equal to msg dot address. msg dot address is the one address not found or visible after argument lookup in the message. This dot address is also not working. I think this is not there in the 0.5.0. So I need to search for where the this particular address is available, because it will vary from version to version. So now in the case of returning of the data also, get name, return company dot name, and here return string, and what it is asking must be memory. Okay. Right. So like this, you can write the company, and if I want to know the managers also, I can write another struct manager. Okay, struct manager, and here string, or you can say uint emp code, employee code, uint 8, not 8, uint pin code to which he allotted. Then I can maintain a structure. I can maintain an indexing like hash mapping with with employee details, either is employee code and employee structure. So that it can be maintained in the company. So that can be maintained like this: manager, manage. You can have list of managers, like say for example 100, like, or you can also use simple hash map that where you can maintain the indexing of manager details. Like, I think you come to know the structures point of view. That will see mapping like this: mapping, key type, and value type. So the key type is whatever the pin code is. Value type is the structure type. So this mapping can be done, and the same mapping can also be used in the company. And MLM contract consisting of company code or company ID, as well as employee code or manager. This mapping can also be placed in the MLM. Okay, this is the way we may also compute this, or we can, like this, we can write any number of structures in the program where some record keeping is required and logging is required. In such cases, you better the related things, whatever the identified roles are there, all those roles can be written in terms of structures, and the main operation between those roles can be written in the main contract. This is the way how we use the structure concept, mapping, and writing the contract for various roles. Next most important thing is validity of the contract. So that is the date and time is required for checking the validity of contract. So for that, we have the data type called date and time. So what is the date and time? That can be represented in terms of days, minutes, seconds, hours, weeks, and years. So directly you can use like this: uint start and uint hours after. If now is greater than or equal to start plus hours after into 3 hours. So here 3 hours, this is the default keyword. Okay, this is the keyword which represents the 3 hours. Okay, hours after start plus. So now means the current time. Now is a default keyword. So this is not a variable. This is a keyword. This represents that after execution, it will give you the universal time. That a universal time, that is the current time. Current time is greater than or equal to the starting time plus hours into 3 hours. Hours after into 3 hours. That means if you want to build a if you want to submit a bid, there is a last date. So there will be a date of announcement of the bid to participate, and also there is a date of completion of the bidding process. So the start time is bidding process start time, that releasing of the notification time, and the end time should be the start time plus the 2 days. So that is what the end time. Now the current time is greater than the end time, then you need to close the contract, bidding contract. So that is what the condition. If any new user is trying to enter it and put the bid or submit the bid, before that you need to check the condition that the current time is there is a deadline time is exceeded with respect to the current time or not. If the current time is all ahead of the deadline time, then the contract will not be executed and contract will be automatically closed. So this is for this purpose. For this purpose, you may go for writing of date and time, and you may use the now operation. Now is the operation used for the current time. Next is unit of ether. You may use Y, penny, sabo, this kind of denominations you can use. Next one is directly you can use like this 2 ether, 2000 penny, like that. Current instance. Then if you want to represent to the current instance, like in C++ and Java, this is a keyword used for representing the current instance. This, the current contract explicitly convertible to the address of class. Other visibility specifier, external functions are part of the contract interface, and they can be called from other contracts. See, with the help of import, you have added some other contracts, and those contracts are included in your program. If you want to call some function in other contract, then you are supposed to use the external keyword for the function. So function f uint a private returns this one. This is an external contract. You can make the external. Next is public visibility. Uint public data inherited. So there is an inheritance concept in the Solidity. One class, one contract can inherit other contract. Like central account and state account. Okay, or state policy, central policy. State policy inherits or extends the central policy. This is the kind of thing. And also, if you might have inherited any function, so what you are supposed to do? Set data is a function available in the super contract or super class kind of thing. Then function set data of uint a inherited. Then what are the data functionalities there that you are supposed to write here? Private functions and store variables are only visible for the contract. They cannot be accessed outside. These are the default functions available in the Solidity code, with which you can get the sensitive information like block hash, coin base, difficulty, gas limit, okay, number, msg.data, msg.gas, msg.sender. So here, whenever I use this company.name, I can say company address is equal to msg. Msg means the one who is operating. msg.sender. Okay, the one who is operating is set to be the message sender. Now, get name. This is the message one, and function get address. Here view. You can also write the same in two ways, like company name comma company dot company address. So you can write multiple functions from one function. For that, string memory comma address. These are the two things you are going to return. So here. So this is the way you are supposed to return this. Like this, you can return any number of values from one function. Just like in your Python program, you can return this. In C programming, you cannot do this. Now let us go for delete this instance and deploy this. Deploy this, then go to the expansion of this, then set. Okay, set 100. whenever I transact, so you just observe here with which address I am transacting. Here 0x5b is the address with which I am transacting. That means I am the person who is doing this message. Okay. Transact. The transaction is successful. Now, if I click get name, I should get the name of the company, or we can say name here is MRF. If I write like this. Okay, the transaction is successful. Then I should get the name of the company, and also I should also get who created this. That I can get via the address. Get name. Okay. So what is the string? MRF, and address is 0x5b38. Whose address is this? This is my address. 0x5b3. So the same address with which I have set the value, this address was recorded. So whenever my contract is initialized, okay, in the constructor of the contract, you can initialize the address of the initializer. So the address of the initializer will become the super user. So then next functions, whatever the functions are there in the contract, has to compare with the super user or the controller of the particular chain address. So if in the same way, like in last lecture we have seen, company has account. So only company can destroy the account. No one can, even manager cannot also destroy the account. So whenever the account is going to be killed, so one thing you are supposed to check is who initiated this killing. So if other than manager, other than company, if other person is initiated this killing, then automatically it has to give an error message that you are not eligible for killing the contract. Only the super user is eligible for. If the company has initiated this contract and deployed this contract, so obviously company will become the super user or the owner of the contract. So if the owner, if it is not owner, and if anyone is trying to kill the contract, then the contract cannot be killed. So for that, we are supposed to use the modifiers. These modifiers will help us in checking the condition before executing of a function. So these are the messages: message.gas, message.sender, message.value, now, etc. Like this, some mathematical operations like post fix, post increment, post decrement, pre decrement, all these things. Whatever you use in our C programming, all these can be used here. And function parameters, already we have explored this function parameters. Next is you can also make use of the cryptographic functions like SHA-3, SHA-256, RIP EMD 160, which is especially used in the ECC. That also you can use cryptographic functions. Next is contract related functions. This means current object. This is current contract. Suicide. I am keep on telling you kill and all. So kill was replaced with a function called suicide afterward. Previously it is suicide. Sorry. Previously it is suicide. Then it was renamed to kill. Suicide means self-destruction of the contract. Suicide current contract sending its fund to given address. This is what they call suicide. And dot balance will give you the balance of the function, balance of the current transaction, current account, and dot send will give you the sending the ethers to other address. So these are the main programming constructs in the Solidity. Next one is some Solidity other features like inheritance. Like for example, contract standard policy, contract state policy is standard policy. Okay, so this is, for example, here I am writing like this: contract figure. Then I am writing contract figure, and here function volume, function volume returns unsigned integer. Okay, return 10 like that. Just I have mentioned like this, and returns is of view public, and here function relevant sources restricted to be queued. Okay, so it is not asking you to go for view. The contract box is figure. So box is a type of figure. This is an extension. So this is the way you will write. Contract standard policies, contract state policies is standard policy. Function definition, name of the function, parameter, visibility modifier, either view or pure, this kind of thing. Access modifier, public, private kind of thing. Returns of returns parameter. Any number of parameters can be returned unlike other programming. Already we have seen that. Here, string memory address and all. So Solidity structure in brief, Solidity is like JavaScript plus Java plus C++ written to target the EVM. Remix IDE is used to code the test and Solidity. So in Remix IDE, it provides three testing environments: JavaScript virtual machine, injected Web3, Web3 provider. So here we have seen that in the deployment. So these are the various environments that is provided. And what are the detailed structure of the Solidity? That includes data or state variables. Here, these are the data variables, state variables, list of functions, constructors. That is the default or user specified. Whenever you won't write anything, that there will be by default instance company. For example, here contract is there, MLM is there. By default, whenever you deploy, by default MLM will be deployed. So it will consider as a MLM contract, MLM constructor. Or if you want to especially specify that, you can specify pure functions, public functions, private functions, internal functions, external functions. External functions can be accessed outside of the contract. Then user-defined functions are user-defined type like structure, enum, modifiers, and events. These are the various details, various things that we can explore in the programming of the Solidity. This thing already we have seen in the last lecture. Okay, this is related to the programming part, and we see one small program here, Pragma Solidity. Just I will remove it. I'm writing a small program that everyone is aware of. Whenever you pick up the Java to complete reference book, this box class will be there. Contract box uint 256 private height uint private height depth uint private width function set dimension uint height uint width uint depth. This is a public height. You can also mention this dot height. That means it refers to current constructor, sorry, current instance. This dot height is equal to height. This dot depth is equal to depth. this dot width is equal to width. So what it is asking, this height is not visible. HEIGHT. HEIGHT. HEI. Okay, I will remove this. I don't know whether. And please remember, you should be very careful in choosing the version. This one. Otherwise, some features will be available, some features will not be available. Now it is accepting. U into 256H. Unused function parameter, remove or comment out variable name to silence one. Remove or comment out variable name. Remove or the problem. The problem we are having is, I think this is the way I should not use this like this. Okay, this dot. Okay, so here H is there. This H has to be assigned to height, depth, and width. When then function compute volume. This is view public returns U int 256. So what is the value to return? Height into depth into width, right? So this is a simple program. Just deploy. Deployment is over. Then height is 10, 10, 10. Then compute volume, you will get 1000. So this is the way you can write the Solidity smart contract code. Okay, I am telling you, I am just giving you the gist of how to write the smart contract code. I hope by this time you come to know how to use the programming constructs that are available. You may also use Solidity documentation, very beautiful documentation available. You can go to the Solidity documentation, introduction to smart contract, and you can see simply just copy it and paste there and see the result. Okay, and copy this and paste there and see how it is working. You understand each and everything, each and every line of the code, like contract coin, address, public, minter, mapping. This is the address mapping. For example, you can also use this mapping in the MLM multi-level marketing contract also, where you can place the manager's address and corresponding pin code like that. You can have the mapping. So whenever I want to get some detail, then balances of the corresponding address will give you this particular value. This is what the mapping is. So you can also use the same mapping here. For example, this is a box, like You can also use mapping. The same structure of mapping can be used here. Just copy it and go to this here, as it was mentioned. Struct company, address, company address, name, string name, uint 256 pin code. Now you can make use of this mapping. So this is the address, and you can map it to company. Okay. Then log company. So this you may include in some contract MLM. Then and copy this. So this is the way you can map it. In future, if you want to access something, then you may set the things like function set company of company instance, then you can place public. There you can place like this log company of msg.addr address is equal to C. Okay. So this one is memory. So it is also required memory because it also requires memory. Member address not found or not visible after message. C dot company address. You can say. So whatever the company address is there, you can place it as an index and corresponding instance. The structure reference can be placed here. So it is just like a telephone indexing. Just by looking at the address, you will get the corresponding data. If you are maintaining a constructor for this, obviously you will be you may also instantiate the message.address, and the same message.address can also be used here. Like that, you can keep on doing many operations. Just I am giving you the general overview of how to write the program and how to use the structure. Depending upon the business logic, you can start using it. So this is related to the Solidity program. So far, if you have any doubt, you may ask me.